Hey guys, as I was reviewing your 070 assignment over 5.2.4 transforming logarithms, I saw a little bit of confusion that was happening and some answers that I wasn't quite looking for. So I'm going to do a little video review of that assignment so that you can kind of reassess where you're at and re-answer a couple of those questions. I put them right here in this Desmos activity, so you don't need to go back to the old one and fix your answers. They will be on the slides to follow. So I really want to point out what is happening on our graph. So for example, this black line is y equals log of x. So that is our parent function for a logarithm. Transformations are the exact same for a logarithm as they were with every other parent function we worked on. So if you look, I'm going to adjust my a value here. That would be the number in front of the log. If I make it negative, you can see that my graph flips across the x. Okay, and then as the number gets bigger, it stretches. When our number is smaller, it compresses. Okay, so specifically, if I'm going to start at 0, if I have a fraction, so between 0 and 1, that's a compression. But then when I surpass 1, I start to stretch. Another way that you could think about it is the smaller the a value, the closer we are to the x-axis. But then again, as soon as it turns negative, it flips across that x-axis. Okay, so that is with a. We have a stretch and compression. Now my h value, that's inside next to the x. So remember, as we change our x, it shifts our equation left and right. So a positive number, so x minus 3, moves it to the right 3. If I had a negative number, so a negative would make me positive, so like an h plus 3, it's going to move to the left. Okay, so just like our other equations. And then lastly, we have the k value. And the k value is on the outside here, and that moves my graph either up or down. So a negative number puts me below the x-axis. A positive puts me above the x-axis. So if I would see a minus 5, that means I'm going down. If I would see a plus 3, I'm going up. And that is how our different values or different variables will adjust our parent function. So quickly, I want to look at an example here. So I have the parent graph is going to be in red, and as I make adjustments, you'll see them happen here in blue. Okay, so if there was a 3 out front here, I can see that this is stretching by a factor of 3. If I add a value on the inside, so plus 3, I can see that that moved over to the left. Okay, and remember, this is centered around the origin. So that origin point is my center of focus, so it shifts it over. And then lastly, if I would subtract 6, I can see that my equation moves down. So the key things I want you to remember is a number on the outside is a stretch or compression. Inside my parentheses gives me a left or right shift. And lastly, a number subtracted or added on the outside is my vertical shift. So go ahead on the next few slides, answer these to the best of your ability. If you are stuck, please rewatch this video because I will be grading the next slides for accuracy. Thank you.